In physics class, students are given a piece of string and a weight and asked to create a timing mechanism like a pendulum. Okay, so there's a formula that says if you know the length of the string on a pendulum, so that distance right there, L, you can take that length, square root it, multiply it by 0.2. This is a number that has to do with how strong gravity is on Earth. And what you'll get out of that is what we call the period of the pendulum, which is how long it takes for the pendulum, starting from one side, to go all the way to the opposite side and back. It has to make a round trip for it to be the full period. And so Courtney's trying to do this to make a pendulum that takes exactly 1 second, the kind that you could base a clock upon. And so how do we solve for that? We've got that the period of a pendulum is 0.2 root L. And she wants the period of this pendulum to be exactly 1 second, so we want 0.2 root L to equal 1. Now, normally if we were solving this, we would divide by 0.2 and then square both sides and get L equals, but they've said they want a radical equation, meaning they don't want us to get rid of this root. So what can we do with this then? We can divide both sides by 0.2. That part's still okay. And that gets us root L equals 1 divided by 0.2 is 5, it turns out. And if it has to be radical, I guess we stop right there. Normally the next step would be L equals 25 after we square both sides, but if they want radical, then there it is. Now, what next? Explain how the length of a pendulum can be determined using the x-intercept of the graph of a radical function. X-intercepts meaning zeros. Well, that means this equation is not quite going to do it. I guess they want one more step. Consider what would happen if we had y equals root L minus 5. I'm taking this 5 over to the left-hand side again, so we get, actually, hang on, I'm just going to change how I wrote that. What I said was true, but it's not the cleanest way to present this. Let me try again. If I take this 5 over to the left-hand side, I get root L minus 5 equals 0. This is what they want us to solve, because the zeros of this equation are equivalent to x-intercepts. If we graph y equals root x minus 5, this is just this with the variables switched up. It's still root something minus 5. And if we try to solve that, here's what happens. What does this look like? We know that root x is like a half parabola arcing to the right, like so. What does the minus 5 do? It isn't inside the root, and so what it does is drop the curve 1, 2, 3, 4, 5 units down, so we actually get a shape more like this. And that point right there represents where root x minus 5 equals 0, which would mean where root x equals 5, which is exactly what we need to get our pendulum problem solved. This is not the cleanest way to write this out, and normally we would have solved this for 25 several minutes ago, but if they want us to do it with a graph of a radical function, then this is how. So the last part of this is sketch the function on a grid, which I've already kind of done. You can do it on graph paper if you want to do a nicer, more precise job. And then find the length of a pendulum with a period of 1 second. I think we found already that the length should be right around 25 centimeters.